Welcome to Galaxy Guru, your front row seat to the universe's wildest wonders. I'm your cosmic guide, Gino, and today we're diving into a story that's been billions of years in the making. A tale of two galaxies on a collision course. One of them is our home, the Milky Way. The other, a galactic giant racing toward us at 250,000 miles per hour. Meet Andromeda, our cosmic neighbor with a deadly agenda. In this video, we'll explore what happens when these two titans collide and what it means for us. But first, let's get to know the star of the show, the Andromeda Galaxy. Part 1. Meet Andromeda, our galactic neighbor. Let's start with a question. Have you ever looked up at the night sky and seen a faint, fuzzy patch of light? If you're in a dark enough place, away from city lights, you might have spotted it. That's Andromeda, the farthest object you can see with the naked eye, 2.5 million light years away. But don't let the distance fool you. Andromeda is hurtling toward us, and in about 4 billion years, it's going to crash into the Milky Way. Don't worry, we've got time to prepare. But what exactly is Andromeda, and why is it so special? What is Andromeda? Andromeda, also known as M31, is a spiral galaxy, just like our Milky Way. It's the largest galaxy in our local group, a collection of over 50 galaxies bound together by gravity. With a diameter of about 220,000 light years, it's more than twice the size of the Milky Way, which spans a mere 100,000 light years. And it's packed with stars, over 1 trillion of them, compared to our galaxy's 200 billion. That's 5 times as many stars, twinkling in the void. But size and star count aren't the only things that make Andromeda impressive. It's also a thing of beauty. If you've ever seen a photo of Andromeda, you know what I mean. A glowing core surrounded by graceful spiral arms, dusted with dark lanes of gas and dust. It's like a cosmic pinwheel, spinning silently in the night. And here's a fun fact. Andromeda is the only galaxy outside the Milky Way that you can see without a telescope. On a clear night, it looks like a smudge of light. But with a good pair of binoculars, you can start to make out its shape. Why is Andromeda special? So why does Andromeda hold such a special place in our hearts and in astronomy? For one, it's our closest spiral neighbor, making it a prime target for study. Astronomers have been observing Andromeda for centuries, using it as a laboratory to understand how galaxies form, evolve, and interact. In fact, it was through Andromeda that we first realized the universe is bigger than just the Milky Way. In the 1920s, Edwin Hubble, yes, that Hubble, used observations of Andromeda to prove that it was a separate galaxy, not just a nebula within our own. That discovery changed everything, opening our eyes to the vastness of the cosmos. But there's another reason Andromeda is special. It's on a collision course with us. Unlike most galaxies, which are moving away from each other as the universe expands, Andromeda is bucking the trend. It's heading straight for the Milky Way, pulled by the relentless force of gravity. And when two galaxies collide, things get interesting. The collision. What's going to happen? Now, before you start panicking, let's clarify what a galactic collision really means. It's not like two cars smashing into each other on a highway. Galaxies are mostly empty space. Stars are spread out, with vast distances between them. So when two galaxies merge, their stars don't usually crash into each other. Instead, they pass through like ghosts, weaving together in a slow motion dance that takes millions of years. But that doesn't mean it's a gentle process. the gravitational tug-of-war between the two galaxies will fling stars into wild orbits, reshape their spiral arms, and trigger bursts of new star formation as gas clouds slam together. It's like two whirlpools swirling into each other, creating a chaotic, beautiful mess. And when it's all over, the Milky Way and Andromeda will have merged into a single giant galaxy, tentatively named Milkomeda by some astronomers. Why should we care? So, why should you care about a collision that won't happen for another 4 billion years? For one, it's a reminder that the universe is always changing. Galaxies aren't static. They grow, merge, and evolve over time. Understanding this process helps us understand the history of the cosmos itself. But there's also a more personal reason. In 4 billion years, the night sky will look completely different. If humanity, or whatever comes after us, is still around, they'll witness a spectacle unlike anything we've ever seen. Two galaxies tearing each other apart and rebuilding into something new. It's a cosmic fireworks show on a scale we can barely imagine. And here's the kicker. This collision might not be the end of the story. There could be more mergers, more transformations as the universe continues to unfold. But that's a tale for another time. What's next? In the next part, we'll dive deeper into the mechanics of galaxy mergers. How do two galaxies actually collide? What happens to their stars, their black holes, their very structures, and most importantly, who's going to come out on top in this galactic showdown? Let's see what else Andromeda has in store for us. So, we met Andromeda, our galactic neighbor, and learned that it's on a collision course with the Milky Way. Next up, we're diving into the heart of the matter. How do galaxies actually merge? What happens when two cosmic giants slam into each other? And what does it mean for the stars, gas, and black holes caught in the chaos? Let's find out. Part 2. Collision Course. How galaxies merge. Let's start with a simple question. What happens when two galaxies collide? If you're picturing a catastrophic smash-up, like two cars crumpling on a highway, think again. Galaxies aren't solid objects. They're mostly empty space with stars scattered like grains of sand on a beach. So, when two galaxies merge, their stars don't usually crash into each other. Instead, they pass through like ghosts, weaving together in a slow-motion dance that takes millions of years. But don't let that fool you. While the stars might not collide, the gravitational tug-of-war between the two galaxies is intense. It's like two whirlpools swirling into each other, their currents twisting and pulling in a chaotic embrace. This gravitational chaos reshapes both galaxies, flinging stars into wild orbits, sparking bursts of new star formation, and potentially merging their supermassive black holes. It's a cosmic ballet of destruction and creation, all rolled into one. The mechanics of a merger. So, how does this dance play out? Let's break it down step by step. Initial approach. As Andromeda and the Milky Way approach each other, their gravitational fields start to interact. This pulls their stars and gas clouds out of their usual orbits, creating long streaming tails of material, like cosmic contrails stretching across the void. These tails are the first signs of the merger, and they can stretch for hundreds of thousands of light years. First pass. Next, the two galaxies begin to pass through each other. Because stars are so spread out, they rarely collide. In fact, the odds of two stars actually hitting each other are about as likely as two mosquitoes colliding in a football stadium. But the gravitational forces are relentless. Stars are flung into new paths, some spiraling toward the center, others catapulted to the galaxy's edges. Gas cloud collisions. As the galaxies intermingle, their gas clouds do collide. Unlike stars, gas is diffuse and can smash together, compressing and heating up. This triggers a fireworks show of new star formation, with gas clouds collapsing into brilliant young stars. It's like striking a match in a room full of fireworks. Suddenly, the galaxy lights up with new life. The role of black holes. Now, let's talk about the heavyweights in this cosmic clash. The supermassive black holes at the center of each galaxy. Both the Milky Way and Andromeda have one. Ours is called Sagittarius, a star, and Andromeda's is even larger. During the merger, these black holes will feel each other's gravity and start spiraling toward the center of the new combined galaxy. This process takes millions of years, but eventually, they'll get close enough to merge themselves, releasing a burst of gravitational waves, ripples in the fabric of space-time. It's like two heavyweight boxers circling each other, throwing punches until they finally collide in a knockout blow. And when they do, the new galaxy will have a single, even more massive black hole at its heart. What will the new galaxy look like? So what happens after the dust settles? When two spiral galaxies like the Milky Way and Andromeda merge, they don't stay spirals. Instead, they transform into a new type of galaxy, an elliptical galaxy. Ellipticals are big, blob-like galaxies with stars orbiting in random directions, like a swarm of bees. They don't have the graceful arms of spirals, but they're often larger and more stable. In the case of the Milky Way and Andromeda, the new galaxy, sometimes called Milkomeda, will likely be a giant elliptical with stars from both galaxies mixed together in a cosmic stew. It's like taking two beautiful sandcastles and smashing them together to build a bigger, shapeless mound. But don't worry, it'll still be a sight to behold, just in a different way. Thanks for joining me on this cosmic adventure. If Andromeda's collision course has you hooked, smash that subscribe button and ring the bell for more. Alright, my friends, we've explored how galaxies merge, how they dance, collide, and reshape each other in a slow-motion spectacle. Next, we're sizing up the two players in this galactic showdown, the Milky Way and Andromeda. Who's bigger? Who's stronger? And what does that mean for the future of our cosmic home? Let's dive in. Part 3. The Milky Way versus Andromeda. Who's bigger? Let's start with a simple question. How do you measure a galaxy? It's not like you can whip out a ruler and stretch it across the cosmos. Instead, astronomers look at a few key metrics: size, diameter, mass, and the number of stars. These numbers give us a sense of a galaxy's heft and influence, like comparing two heavyweight boxers before a title fight. So, let's put the Milky Way and Andromeda in the ring and see how they stack up. Size, diameter showdown. First up, size. The Milky Way is a barred spiral galaxy with a diameter of about 100,000 light-years. That's huge. Light itself takes 100,000 years to cross from one side to the other. But Andromeda, it's even bigger. With a diameter of approximately 220,000 light-years, Andromeda is more than twice as wide as the Milky Way. If galaxies were pizzas, the Milky Way would be a personal pan, and Andromeda would be a family-sized feast. But wait, there's a twist. Recent studies suggest the Milky Way might be larger than we thought. Some estimates put its diameter closer to 150,000 light-years, thanks to a halo of stars and gas extending beyond the visible disk. Still, even with this boost, Andromeda holds the size advantage. It's like comparing a small city to a sprawling metropolis. Andromeda's got more real estate. Mass, the heavyweight battle. Next, let's talk mass. Mass is a galaxy's gravitational muscle. The more mass, the stronger its pull. The Milky Way's total mass is estimated at around 1 trillion solar masses. That includes stars, gas, dust, and the invisible dark matter that holds it all together. Andromeda, on the other hand, tips the scales at about 1.5 trillion solar masses. That's 50% more mass than the Milky Way, a significant edge. But here's where it gets interesting. Mass isn't just about who's heavier, it's about who can throw their weight around. In a galactic merger, the more massive galaxy often dominates, shaping the structure of the new, combined galaxy. So, with Andromeda being the heavier hitter, does that mean it's going to win the merger? Not so fast. There's more to this story. Star count, a stellar census. Now, let's count the stars. The Milky Way is home to about 200 billion stars, give or take a few billion. That's a mind-boggling number, but Andromeda blows it out of the water with over 1 trillion stars. That's 5 times as many stars, twinkling in its vast spiral arms. It's like comparing a small town to a megacity. Andromeda's population is just bigger. But again, there's a twist. While Andromeda has more stars, the Milky Way might have a higher density of stars in its central regions. Our galaxy's core is packed with stars orbiting the supermassive black hole Sagittarius A star, while Andromeda's core is more spread out. This could affect how the merger plays out. Think of it like two armies clashing, where one has more soldiers but the other has a tighter formation. The black hole factor. Speaking of black holes, let's not forget the heavyweights at the center of each galaxy. The Milky Way's black hole, Sagittarius A star, has a mass of about 4 million solar masses. Andromeda's black hole is even larger, weighing in at around 100 million solar masses, 25 times bigger. That's a significant difference, and it could play a role in the merger. When the two galaxies combine, their black holes will eventually merge too, and the larger one, Andromeda's, might dominate the new galaxy's core. But here's a fun fact. Black holes don't just sit there. They can fling stars around like cosmic slingshots, especially during a merger. So even though Andromeda's black hole is bigger, the chaos of the collision could send stars from both galaxies flying in all directions. It's like two kings battling for control of a new kingdom. Only the kingdom is made of stars. So, who's going to win? Now, the million-dollar question. Who's going to come out on top in this galactic showdown? Based on size, mass, and star count, Andromeda seems to have the upper hand. It's larger, more massive, and packed with more stars. But in galaxy mergers, it's not always about who's bigger. It's about how the two galaxies interact. For example, the Milky Way's denser core could give it an edge in shaping the new galaxy's center. Andromeda's larger size might mean it has more influence over the outer regions. It's like two chefs combining their recipes. One might dominate the main course, but the other could steal the show with dessert. Ultimately, the new galaxy, tentatively called Milkomeda, will be a blend of both, with stars from the Milky Way and Andromeda mixing together in a cosmic stew. But if we had to pick a winner, Andromeda's greater mass might give it a slight edge in shaping the final product. In the next part, we'll explore the timeline of this cosmic collision. When will it happen? How fast is Andromeda approaching? And what will the night sky look like as the merger unfolds? And so, we're diving into the timeline of this galactic showdown. When will Andromeda and the Milky Way collide? How fast is Andromeda approaching? And what will the night sky look like as the merger unfolds? Let's find out. Part 4. The timeline. When will it happen? Let's start with the big question. When is this cosmic collision going to happen? The answer, according to astronomers, is in about 4 billion years. That's a long time, almost the entire age of our solar system, which is 4.6 billion years old. But in the grand scheme of the universe, it's just a blink of an eye. Galaxies move slowly and mergers take time. But here's the thing, 4 billion years is a rough estimate. The exact timing depends on factors like the precise distance between the two galaxies and their relative speeds. So, how do we know it's coming at all? And how fast is Andromeda actually moving toward us? Andromeda's speed? A galactic sprint. Right now, Andromeda is about 2.5 million light-years away from the Milky Way. That's a staggering distance. Light itself takes 2.5 million years to travel from Andromeda to us. But despite that, Andromeda is closing in at a speed of about 110 kilometers per second or 250,000 miles per hour. That's fast enough to cross the United States in about 10 seconds. But in cosmic terms, it's a leisurely stroll. Wait a minute. If the universe is expanding, shouldn't galaxies be moving away from each other? That's true for most galaxies, but Andromeda is an exception. It's close enough that gravity is pulling it toward us, overpowering the expansion of space. It's like two people on a stretching rubber band. If they're close enough, they can still reach each other despite the stretch. The approach. A slow-motion crash. So, how does this timeline play out? Let's break it down. Today, Andromeda is 2.5 million light-years away, moving toward us at 110 kilometers per second. At this speed, it would take over 6 billion years to reach us. But that's not the whole story. As the two galaxies get closer, gravity will pull harder, speeding up the approach. In 2 billion years, Andromeda will be noticeably closer, and its gravitational influence will start to distort both galaxies. Stars on the outer edges might be flung into wild orbits, creating long streaming tails of stars and gas. In 4 billion years, the first close encounter. Andromeda and the Milky Way will pass through each other, their stars intermingling like two swarms of bees. This is when the real chaos begins. In 5 to 6 billion years, the two galaxies will swing around and collide again, this time merging more fully. Over millions of years, they'll settle into a new, combined galaxy, likely an elliptical shape with stars orbiting in random directions. But here's a fun fact. The entire merger process will take hundreds of millions of years. It's like watching two clouds slowly blend together, a slow-motion spectacle on a cosmic scale. What will the night sky look like? Now, let's imagine you're a future astronomer living a few billion years from now. What will you see in the night sky as Andromeda approaches? Today, Andromeda is a faint, fuzzy patch, visible only in dark skies. But as it gets closer, it will grow brighter and larger, eventually dominating the night sky. In 2 billion years, Andromeda will be a massive glowing disk stretching across a huge swath of the sky, bigger than the full moon. It'll be the brightest object in the night, casting faint shadows on moonless nights. During the merger, the sky will be a chaotic swirl of stars with the two galaxies' arms tangling and intertwining. New stars will burst into life as gas clouds collide, lighting up the night with brilliant nebulae. It'll be a once-in-a-lifetime show, except it'll last for millions of years. But here's the catch. By the time the merger happens, our sun will have become a red giant, swallowing Earth in its fiery embrace. So, unless we found a new home by then, we won't be around to see it. But let's not dwell on that. There's still plenty of time to figure it out. You might be thinking, 4 billion years is a long time. Why should I care about something so far in the future? Fair point. But understanding the Milky Way's fate helps us understand the universe's bigger picture. Galaxies merge all the time. It's how they grow and evolve. By studying Andromeda's approach, we can learn about the processes that shape the cosmos. Plus, it's a reminder that nothing in the universe is permanent. Stars are born and die, galaxies merge and transform, and even the universe itself is expanding. Change is the only constant, and that's a lesson worth remembering. In the next part, we'll explore what the collision will look like up close. What happens to the stars, the gas, and the black holes when two galaxies smash together? And most importantly, what does it mean for our little corner of the universe? Stay tuned to Galaxy Guru as we continue our journey through the stars. All right, my friends, we've explored the timeline of the Milky Way and Andromeda's epic collision, set to happen in about 4 billion years. Next up, we're diving into what this galactic merger will actually look like. Imagine the night sky ablaze with stars from two galaxies tangling in a cosmic dance. What will this epic collision look like? Let's find out. Part 5. The collision. What will it look like? Let's start by setting the scene. It's billions of years in the future, and the night sky is no longer the familiar canvas of constellations we know today. Instead, a massive, glowing disk dominates the heavens. Andromeda, our galactic neighbor, has arrived. Over millions of years, it's grown larger and brighter until it stretches across the sky like a cosmic tidal wave. But this is just the beginning. As Andromeda and the Milky Way begin their slow-motion crash, the real spectacle unfolds. A cosmic dance of stars. So, what does a galactic collision actually look like? It's not a sudden, explosive event like two cars smashing into each other. Instead, it's a graceful, chaotic dance that plays out over millions of years. As the two galaxies approach, their gravitational fields start to tug at each other, pulling stars and gas out of their usual orbits. Imagine two whirlpools swirling together. Their currents twist and pull, creating long, streaming tails of stars and gas that stretch across the sky like cosmic contrails. These tails are the first visual signs of the merger, and they can be spectacular. Stars from both galaxies are flung into wild, looping orbits, some spiraling toward the center, others catapulted to the edges. It's like a cosmic game of pinball, with stars bouncing around in a gravitational playground. Gas clouds collide, sparking stellar fireworks. But the real fireworks happen when the gas clouds collide. Unlike stars, which are spread out and rarely hit each other, gas is diffuse and can smash together. When it does, it compresses and heats up, triggering a burst of new star formation. Picture two clouds of glitter colliding in slow motion. Suddenly, the air is filled with sparkling new points of light. That's what's happening on a galactic scale. New stars burst into life, lighting up the night with brilliant nebulae and star clusters. It's a stellar baby boom, fueled by the chaos of the merger. These new stars will be some of the brightest objects in the sky, shining like cosmic beacons. If you were watching from a planet in the merged galaxy, the night sky would be a dazzling display of starlight, with constellations we can't even imagine. The fate of the black holes. Now, let's talk about the heavyweights in this cosmic clash. The supermassive black holes at the center of each galaxy. The Milky Way's black hole, Sagittarius a star, and Andromeda's even larger black hole will feel each other's gravity and start spiraling toward the center of the new combined galaxy. It's like two heavyweight boxers circling each other, sizing up their opponent before the final showdown. This process takes millions of years, but eventually, they'll get close enough to merge, releasing a burst of gravitational waves, ripples in the fabric of space-time. It's a cosmic knockout punch, and when it's over, the new galaxy will have a single, even more massive black hole at its heart. What will the sky look like? So, what will all this look like from Earth, or whatever planet we might be living on by then? Well, if we're still around, the night sky will be a sight to behold. As the two galaxies intertwine, their spiral arms will stretch and distort, creating a tangled web of stars and gas. The sky will be filled with new constellations, unfamiliar patterns of light that shift over time as the merger progresses. And here's a wild thought. During the peak of the merger, the sky could be so bright with new stars and nebulae that night itself might be a thing of the past. It's like living in a city that never sleeps, with the lights of the cosmos always shining. Will we survive? Now, you might be wondering, will we even be around to see this? The answer is probably not. By the time the merger happens, our sun will have become a red giant, swallowing Earth in its fiery embrace. But let's say humanity, or whatever comes after us, has found a new home by then. What would they see? A sky transformed, with stars from both galaxies mixing together in a cosmic stew. It's a reminder that the universe is always changing, and that even the most familiar things, like the night sky, can be remade. In the next part, we'll explore what this collision means for our little planet. Will Earth survive the galactic merger? And what will happen to the solar system as the galaxies collide? Stay tuned to Galaxy Guru as we chase the galaxy's deepest secrets. Okay, we explored what the Milky Way and Andromeda's epic collision will look like. A slow-motion dance of stars and gas, reshaping the night sky. Next, we're tackling the big question. What does this mean for Earth? Will our planet survive the galactic merger? And what will happen to our solar system as these two giants collide? Let's find out. Part 6, Earth's fate. Will we survive? Let's start with the question on everyone's mind. Will Andromeda eat us? The short answer is no. Earth isn't going to be swallowed up or destroyed by the collision. But that doesn't mean we're completely off the hook. The merger will reshape the galaxy. And while the odds are in our favor, there are some wild possibilities to consider. So, let's break it down. Why Earth will likely survive? First, let's talk about why Earth is probably safe. When two galaxies merge, it's not like two solid objects smashing into each other. Galaxies are mostly empty space, stars are spread out, with vast distances between them. In fact, the average distance between stars in a galaxy is about 5 light years. That's like the distance from here to the nearest star system, Alpha Centauri. So when the Milky Way and Andromeda collide, their stars will pass by each other like two swarms of bees flying through one another. The chances of any two stars actually hitting each other are incredibly small, almost zero. That means our Sun, and by extension Earth, won't be directly impacted by a stellar collision. It's like two flocks of birds flying through each other. There might be some ruffled feathers, but no crashes. So from that perspective, Earth is safe. Gravitational chaos, a wild ride for the solar system. But here's where it gets interesting. While stars won't collide, the gravitational forces during the merger will be intense. As the two galaxies tangle, their gravitational fields will tug and pull on each other, flinging stars into new orbits. Some stars might be thrown toward the center of the new galaxy, while others could be catapulted to the outer edges or even ejected from the galaxy entirely. So, what does that mean for our solar system? Well, it's possible that the Sun could be sent on a wild ride. It might end up in a completely different part of the galaxy, far from where it started. Imagine waking up one day to find your house has been moved to a new neighborhood. Except in this case, the neighborhood is a few thousand light years away. It's a bit disorienting, but as long as the Sun's planets stay in orbit, Earth should be fine. There's also a small chance, very small, that our solar system could be ejected from the galaxy altogether, sent drifting into intergalactic space. But don't worry, the odds of that happening are slim, and even if it did, Earth would still be safely orbiting the Sun. It's like being kicked out of a party, but still having your friends with you. The night sky, a dazzling new display. Now, let's talk about what we'll see. If Earth is still around during the merger, and that's a big if, considering the Sun's own life cycle, the night sky will be unrecognizable. As the two galaxies intertwine, stars from Andromeda will mix with those from the Milky Way, creating entirely new constellations. The sky will be a swirling canvas of light with stars from both galaxies dancing together. And it's not just the stars. The collision will trigger bursts of new star formation as gas clouds from both galaxies slam together. These new stars will light up the night, creating brilliant nebulae and star clusters. It's like the galaxy's own fireworks show, celebrating the birth of a new cosmic structure. But here's a thought. Could we one day call a star from Andromeda our neighbor? Absolutely. In the merged galaxy, stars from both the Milky Way and Andromeda will be thoroughly mixed, like two decks of cards shuffled together. Your nearest stellar neighbor might have once been part of Andromeda, billions of light years away. Indirect effects, radiation and star formation. Now, while Earth won't be directly harmed, there could be some indirect effects to consider. For example, the merger will create regions of intense star formation, and with that comes increased radiation from supernovae and other high-energy events. If our solar system ends up near one of these active regions, Earth could be bathed in higher levels of cosmic rays. It's like moving closer to a bonfire. You might feel the heat, but as long as you're not too close, you'll be okay. That said, space is vast, and the odds of ending up in a dangerous spot are low. Plus, Earth's atmosphere and magnetic field do a great job of protecting us from cosmic radiation. So, while it's something to think about, it's not a major concern. The bigger picture, a new galactic home. Let's zoom out for a moment. The merger of the Milky Way and Andromeda will create a new galaxy, tentatively called Milkomeda. And it will be a different beast altogether. Instead of two spiral galaxies, we'll have one giant elliptical galaxy, with stars orbiting in random directions like a swarm of bees. It's a whole new cosmic neighborhood, and Earth, if it's still around, will be part of it. But here's the thing. By the time this happens, our sun will have become a red giant, swallowing Earth in its fiery embrace. So, unless humanity has found a new home by then, we won't be around to witness it. But let's imagine for a second that we do survive. What would it be like to live in this new galaxy? The night sky would be a blend of familiar and strange, with stars from both galaxies shining together. It's a reminder that the universe is always changing, and that even the most familiar things, like our galactic home, can be transformed. In the next part, we'll explore what this new galaxy might look like. What will it be called? How will it evolve? And what does it mean for the future of the universe? Stay tuned to Galaxy Guru as we chase the galaxy's deepest secrets. Alright friends, we are really moving through this cosmic adventure that's been billions of years in the making. In the last section, we explored Earth's fate during the Milky Way and Andromeda's epic collision. And the good news is, our planet will likely survive the chaos. Next up, we're looking beyond the collision to the galaxy that will emerge from this cosmic merger. What will this new galaxy look like? What will it be called? And what does it mean for the future of the cosmos? Let's dive in. Part 7. A new galaxy. What will it be called? Let's start with a question. What happens when two galaxies merge? We've talked about the collision, the chaos, and the fireworks. But what's the end result? When the dust settles, the Milky Way and Andromeda won't just bounce off each other like bumper cars. Instead, they'll combine to form a brand new galaxy, a cosmic blend of stars, gas, and dust from both. It's like mixing two different recipes to create a dish that's entirely new. And in this case, the dish is a galaxy. So, what will this new galaxy be called? Astronomers have playfully dubbed it Milkomeda, a mashup of Milky Way and Andromeda. It's a fun name, but it's not official yet. In reality, the naming of galaxies often comes from their location, shape, or the astronomers who discover them. But since this galaxy won't form for another 4 billion years, we've got plenty of time to decide. Maybe future civilizations will come up with something even better. For now, Milkomeda it is. What will Milkomeda look like? Now, let's talk about what Milkomeda will actually look like. The Milky Way and Andromeda are both spiral galaxies with their graceful arms and bright cores. But when two spirals merge, they don't stay spirals. Instead, they transform into something different, an elliptical galaxy. Ellipticals are big, blob-like galaxies with stars orbiting in random directions like a swarm of bees around a hive. They don't have the neat, organized structure of spirals, but they're often larger and more stable. Why does this happen? During the merger, the gravitational chaos scrambles the orderly orbits of the stars, erasing the spiral arms and creating a more uniform, spherical shape. It's like taking two neatly coiled garden hoses and tangling them into a knot. Once they're mixed, you can't untangle them back into spirals. But here's the thing. Milkomeda won't just be any elliptical galaxy. It'll be a giant elliptical, one of the largest in the local universe. With the combined mass of the Milky Way and Andromeda, it'll be a true cosmic heavyweight, dominating our corner of the cosmos. The fate of the stars and black holes. So, what happens to the stars from both galaxies? Will they mix together like ingredients in a cosmic stew? Absolutely. In Milkomeda, stars from the Milky Way and Andromeda will be thoroughly blended, orbiting the new galaxy's center in a chaotic dance. It's like shuffling two decks of cards together. Once they are mixed, you can't tell which card came from which deck. But it's not just the stars. The supermassive black holes at the center of each galaxy will also play a starring role. As the merger progresses, these black holes will spiral toward each other, eventually merging into a single, even more massive black hole. This new black hole will sit at the heart of Milkomeda, pulling the strings of the entire galaxy. It's like two kings combining their kingdoms under one crown. Only this crown is a black hole billions of times more massive than the Sun. A new home for the solar system. Now, let's think about our own solar system. In part 6, we learned that Earth will likely survive the merger, but our address might change. The Sun could be flung to a new part of the galaxy, far from where it started. In Milkomeda, our solar system might end up in the outer suburbs, orbiting the center from a great distance. It's like moving from a bustling city center to a quiet, rural town. Same galaxy, different vibe. But here's a wild possibility. Some stars could be ejected from the galaxy entirely during the merger, sent drifting into intergalactic space. If that happens to our solar system, we'd be floating in the void with no galaxy to call home. It's unlikely, but not impossible. Imagine looking up at the night sky and seeing nothing but distant galaxies, our own Milky Way, a fading memory. The timeline. When will Milkomeda stabilize? So, how long will it take for Milkomeda to settle into its new form? The initial collision will happen in about 4 billion years, but the merger process will take much longer. After the first pass, the two galaxies will swing around and collide again, like two dancers in a cosmic tango. Each pass will mix their stars and gas more thoroughly, until after hundreds of millions of years, they finally settle into a stable, elliptical shape. It's a slow process. Think of it like kneading dough. You have to fold and press it over and over until it's fully mixed. In the same way, the galaxies will need multiple encounters to fully merge. But once they do, Milkomeda will be a new, unified galaxy with its own unique structure and history. What does this mean for the universe? Now, let's zoom out and think about the bigger picture. Galaxy mergers are common in the universe. It's how galaxies grow and evolve. In fact, the Milky Way has already merged with smaller galaxies in the past, and it'll likely do so again in the future. But the merger with Andromeda is special because it's a clash of titans, two of the largest galaxies in our local group coming together. This merger will also have ripple effects on the local group itself. Milkomeda will be the dominant galaxy, pulling smaller galaxies into its orbit like a cosmic overlord. It's like a small town growing into a bustling city, attracting new residents from the surrounding countryside. And here's a thought. Could Milkomeda one day merge with even more galaxies? It's possible. The universe is a dynamic place, and galaxies are always on the move. But that's a story for another time. In the final part of this video, we'll explore what lies beyond the merger. What's next for Milkomeda? How will it evolve over billions of years? And what does this tell us about the fate of the universe itself? Let's find out. Okay friends, we just explored the birth of a new galaxy, Milkomeda, formed from the merger of the Milky Way and Andromeda. Finally, we're looking beyond the merger to the future of the universe. What's next for Milkomeda? How will it evolve over billions of years? And what does this tell us about the fate of the cosmos? Let's dive in. Part 8. Beyond the merger. What's next for the universe? Let's start with the simple truth. The universe is always changing. Stars are born and die, galaxies merge and transform, and the cosmos itself is expanding. The merger of the Milky Way and Andromeda is just one chapter in a much larger story, a story that's been unfolding for 13.8 billion years and will continue for trillions more. So, what's next for Milkomeda, the new galaxy born from this cosmic collision? And what does its future tell us about the universe at large? The evolution of Milkomeda. First, let's talk about Milkomeda's future. Once the merger is complete, Milkomeda will settle into its new form as a giant elliptical galaxy. Ellipticals are different from spirals. They don't have the graceful arms or the active star formation. Instead, they're more like cosmic retirement homes filled with older stars coasting through their twilight years. So, what does that mean for Milkomeda? Star formation slows. In the early days after the merger, there might be a burst of new star formation as gas clouds collide. But over time, that gas will be used up or expelled, and star formation will grind to a halt. Milkomeda will become a quieter place with fewer young, bright stars lighting up the night. A stable structure. Elliptical galaxies are stable. They don't have the dynamic spiral arms or the chaotic star-forming regions. Milkomeda will likely remain in this state for billions of years, its stars orbiting the center in random directions like a swarm of bees. Black hole dominance. At the heart of Milkomeda will be a supermassive black hole formed from the merger of the Milky Way and Andromeda's black holes. This black hole will continue to grow, occasionally feasting on stars or gas that wander too close. It's like a cosmic dragon, lurking in the center, waiting for its next meal. But here's the thing. Even elliptical galaxies aren't completely static. Over trillions of years, Milkomeda could evolve further, perhaps merging with other galaxies or slowly fading as its stars burn out. It's a slow process, but change is inevitable. The local group, a cosmic neighborhood. Now, let's zoom out and think about the bigger picture. Milkomeda won't be alone in the universe. It'll be part of the local group, a collection of over 50 galaxies bound together by gravity. In fact, Milkomeda will likely become the dominant galaxy in the local group, pulling smaller galaxies into its orbit like a cosmic overlord. Some of these smaller galaxies, like the Triangulum galaxy, might even merge with Milkomeda in the distant future, adding to its bulk. It's like a small town growing into a bustling city, attracting new residents from the surrounding countryside. Over billions of years, the local group could coalesce into a single supergiant galaxy, a process that's happening in galaxy clusters all across the universe. The universe's bigger story, expansion and isolation. But let's zoom out even further. What does the future hold for the universe as a whole? The answer lies in the universe's expansion. Right now, the universe is expanding, with galaxies moving away from each other like dots on an inflating balloon. But gravity still holds galaxy clusters together, like the local group. In the distant future, trillions of years from now, the expansion will have carried most galaxy clusters beyond the observable horizon. That means Milkomeda, or whatever it becomes, will be alone in the visible universe, with no other galaxies in sight. It's a lonely fate, but one shared by all galaxies as the universe ages. The human perspective. Why this matters now, you might be wondering. Why should we care about something that won't happen for billions of years? Fair question. For one, it's a reminder that the universe is always changing. Stars are born and die. Galaxies merge and transform, and even the universe itself is evolving. Understanding this process helps us understand our place in the cosmos. But there's also a more personal reason. The story of Milkomeda is a story of transformation and renewal. Just as the Milky Way and Andromeda will merge to create something new, we too are constantly evolving, growing, and adapting. It's a cosmic lesson in resilience and change, a call to curiosity. As we wrap up this video, let's take a moment to reflect. The collision of the Milky Way and Andromeda is a reminder that the universe is full of surprises, and that even the most familiar things, like our galactic home, can change in ways we can't imagine. But it's also an invitation to keep exploring, to keep asking questions, and to keep looking up. So, what's next for you? Whether you're a seasoned astronomer or just a curious stargazer, there's always more to discover. The universe is vast, and we've only just begun to explore it. Keep chasing the stars, and who knows what secrets you'll uncover. Thank you for joining me on this stellar journey through the Milky Way and Andromeda's epic collision. If this video has sparked your curiosity, like the video, smash that subscribe button, and ring the bell for more cosmic adventures. Thank you. Let us know what you want to hear about next in the comments. The universe is waiting. Let's explore it together. Until next time, keep your eyes on the stars and your mind wide open.